over 6 is 2 over 3.
All right, let's talk it out.
Oh, yeah.
You've had time to work on it your own. Maybe get stuck
You got stuck on
and
C.
collaborate in groups. On C?
All of us.
Did you make it to D?
Nope. No.
I have to work on my graph.
All right. Going purple. How would you describe what's going on?
A vertical stretch.
No, keep going. Okay, so vertical stretch. Okay, now what's changing if it's just a vertical stretch? The y values, right? So I take the 2, and instead of adding 4 like B, what am I going to do? Multiply by 2, and 2 times 2 is? Okay, what am I going to do with this one? Multiply the y by, which will be negative 4. Multiply the y by 2, which will be negative 4. Multiply the y by 2, which will be, because it's a vertical stretch by y, by 2, the y's double. The y's double, the x's double.
What? I don't understand why we kept the base there, though. That's
Get the base where?
Because I thought like this. As the negative 2 and the negative 2, the 0 and negative 2, their slope is 0. It's actually 0 over 2. So we just kept them there.
Their slope is, but we're not changing slope, we're changing y's.
Because vertical stretch is pretty much changing the slope, aren't you?
Not necessarily, though. Okay, imagine holding a rubber band, yeah?
Yes.
And imagine holding, putting multiple fingers in a rubber band. Okay, so let's say you have 3 fingers in a rubber band. 2 of them are flat and 1 of them is up. When you stretch, aren't these still 2 flat? Let's see how the rubber band. Right? When you stretch, they're still flat. So the slope doesn't always change. Does the slope sometimes change? Yes. But does the slope always change? No. So if I was to keep these 2 flat, and then this one go up. Let's see if I can actually do the flat, right? If I stretch vertically, which would be technically stretching this up, they're still flat at the bottom. Does that make sense? It's stretched. The whole thing is
But
stretched.
they went down.
This went down.
We didn't bring them down, that's the problem.
Well,
When you stretch, you go like
when I
this.
stretch straight up, it's a similar, it's not a similar shape necessarily. Similar in geometry means like the exact same angles. It's not the exact same angles. But if I have it here, and if I stretch, right? This goes down, this goes up, but this is still flat. Does that make more sense? So that's why it's still flat. Okay. No, it's okay. It was a good idea. For calculus, it's a good idea. Thinking of slopes just doesn't apply here. D. How did you guys verbally describe what was going on? What color haven't I used? Red?
Yeah. Vertical, but
Reflection in the x-axis, that's good. I'm going to use vertical just because it helps me remember, and it's on the outside. Is that okay? But it is reflection in the x-axis. And what's going on the inside?
translate right.
Yeah, so it's going to shift right 4, right? Now how do we do that, though?
Well,
Vertical flip first is what I would do. Or you could do, what did you guys do, the shift or the flip?
I just like,
Yeah, that's what I was thinking too. You could have technically gone 4 and then shifted and then flipped it, but sorry, you could have went 4 and then flipped. But I'm going to flip. So instead of 6, negative 2, it's going to be 6. Sorry, instead of 6, positive 2. It's going to be 6, negative 2, right? And then it's going to go right 4. So it's going to be 10, negative 2. Okay? I think with these graphs, the easiest way is 1 point at a time. Same thing with this one, in that 0, negative 2 becomes 0, positive 2. But 0, positive 2 is going to become 4, positive 2. Right? Negative 2 is going to become negative 2 positive 2 and then shift 4. Negative 4 positive 2 will become negative 4 negative 2 and shift 4. What is this exercise showing? Technically, most functions can be kind of narrowed down to a certain number of points. And if you're totally stuck, you could technically take those few key points and perform the transformations on those and then go ahead and connect them in the nature of the function. This one, it's straight lines. Zoom, 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 zoom. Parabolas, it'd be a curve. Cubics, it would be, well, kind of a swoopy swoop curve, right? Depending on which way it's oriented, if it's been flipped, etc. You can technically narrow a function down to a few key points, do the transformations to those few key points, and then go ahead and sketch connect them in the nature of the function. Letter E. Now what? Okay, let me get something else. There we go. Vertical shift. So we just say down 3, is that okay? Okay. So then instead of being negative 4, 2, it could be negative 4. That'd be like halfway, huh? That's awkward. That's okay. And instead of being negative 2, it's going to be 2 and then one more. Like a half tick mark. This one's the same place. This one is down 2 and down one more. Oh, it's a nice one, huh? I think the ocean. Okay. Down 3. Number next one. Trying to think of something different that'll stand out. There are kind of 2 different ways of going about this one. What did you guys look at first, the negative or the minus 1? The negative. I see a negative, right? It's on the outside. That means it's a vertical flip.
I see the minus.
But some of you might see the minus 1 first, which means a shift down.
Because I moved it and then you flip it.
You moved it down and then flipped it up?
Oh, it's algebraically wrong, right? Because you gotta do the multiplying first.
It's hard, right? Which one do we do first? We'll come up with the same graph.
Yeah.
If we flip and then move down, will that be the same thing as moving down and then flipping? Huh?
Down is always down and up is always up. So if you're going to go down 1, it doesn't matter if you go after you multiply or before.
True. Except, here's the problem. The reflection is about the x-axis, right? So here's, if we go down 1, and if we think then flipping about, well,
It's not going to be on.
we're not reflecting in the x-axis. We're doing it out of order. So it's going to be smarter. If you want to think PEMDAS, it's going to be smarter to deal with multiplication and then shift. Yeah, I agree. In the sense of we could flip and have the negative 4 go down to negative 2, and then do the shift down 1. Let's see, negative 2 would be there and down 1. There we go. We could flip this one, which is at negative 2 to negative 2, positive 2, and then go down 1. We could flip him, which would be positive 2, but then down 1. And we could flip him, which would be now negative 2, but then down 1. So if we did it in the other order, we might accidentally end up kind of ultimately going up 1, and that's not good. Oh, that connection was awful. So this would be a vertical flip. And this just kind of helps you that, hey, order does matter on these. Does that make sense? Yeah. Okay. We have one more. Whew. Horizontal stretch by a factor of? Oh, 1/2. 1/2. Remember, horizontal is backwards what you think. I wish it wasn't, but it is. This is going to be a horizontal, technically compression. We could say, though, horizontal dilation. Look, Mr. Shanks will be proud. by 1/2. What does that do? It squishes it. How? Horizontally. How? Instead of going 6-2, where's it going to be? 3-2. You see it? Instead of being 0, -2, it's going to be, well, what's half of 0? Still 0. He remains. But instead of going over -2, it's only going to go over -1. And instead of going over -4, it's only going to go over -2. Alright, hence why the different colors. Now, if you had all these different colors at your disposal, you could do number 10 in one graph, but that's pretty nasty and disgusting. So you could have also done 7 different graphs, or maybe 3 different graphs with a couple each, right? That would have been a little bit less hectic. But for those of you who got stuck on number 10 last night, right? Think about it as to what's going on first. Then go to your points and perform the transformation. Bring. Think of it this way. When I multiply, do I have one? Okay. This new point was at 3, right? If I plug 3 in, and if it gets doubled, it has the y value of what was 6. So at 3, it'll have the same result. 3 times 2 is 6 as 6. So what point used to be at x is 6 is now at x is 3. Get through it. It's a little rough. But if I plug in 3, I get f of 6, so I get to steal that value. Because it'll happen in half the time, half the distance. In the sense of, I used to have to plug in, think of normal f of x, I had to plug in 6 to get 2. But now I only have to plug in 3 f of 6 to get that 2. Does that kind of make, no, it's hard. I think that's a really hard concept, and I think probably half the kids are like, I have no idea what she's talking about. It's hard. But that's what's going on.
So, vertical stretch, you're only multiplying the y, and horizontal stretch, you're only multiplying the x. Okay.
But horizontal is always backwards, what you think. So if it's a minus on the inside, you go right. If it's a plus, left. If you multiply by 2, it gets cut in half. And if you multiply by a half, it gets... Let's go think of the evens and see what you guys were able to get.
Oh, at the end of the test, I'm going to forget it.
It's okay, we'll practice. We'll practice. Oh, that 10 is not going to show up very well. Hold on. You guys see 4? You can see 4 of these, right? Yeah. Matching, how do we do? We get number 4. I know 10. We're like, but 4 we're looking at. 4, 2, 3, 1. Okay, number 10. Can I zoom in? Yeah. All right. Got it. Is this page 1? Yeah. All right, let's start there. Now, they did what I did in the sense of verbally thinking it through and then trying to mimic. And you see how they just chose the certain points to flip or do the transformation? So right 5. Flip it, which meant, where's my original graph? That's no fun. It was at 0, 5, right? Something like that. Flip it, and then up 1. No, sorry, up 3. That's okay. Flip it first, and then up 3. Do you see how they did the reflection and then the shift? That order is important. This one. Why is it shrinking? It's a 1/3. You would think it shrinks, right? The y's get multiplied by 1/3. And you're like, but it looks bigger. Okay, hold on. Look at the scale, right? This would be, it'd be way down here. So it got cut to be 1/3 is high and 1/3 is low. y value each y is multiplied by. Let's keep scrolling down. Letter D. And guys, remember, I'm taping this, right? Ah, so a few of you are like, okay, then go look at the video. Take some time with it, okay? After the warm-up, hopefully it'll help. D, reflection first, and then shift it left one, right? Reflection first, shift it left one. Letter E, he's a nice one. Just flip him, but how? Hey, was that much of a difference? He stays the same. That's nice. Happens every now and then. And then letter F just goes down.
So we should love just reflections.
Mm-hmm. Well, as long as it's the same thing on both sides. As long as it, what symmetry is that? Y-axis symmetry, or it's, what type of function? Even. Even. Even functions. We like those because that reflection is nice. Okay. Was there one more? I think there's one more, right? G? Okay. Let's go find it. Wait. Stretch? No. There's a 1/3. You flip it, right? Remember, you flip it. So it is going to be horizontally stretched. What was at 6 is now times 3 at 18. Because, Brandon, we plug in at 18, it acts like 6. Yeah? We'll keep working. Alright, ready to go for 46? And those of you that weren't able to track with 10, you're going to work on it a little bit more and then come back to it in a second. Okay. Number 46. Who's the parent function? Oh, you guys got this from yesterday, right? Where's the x? Take away all the extra stuff. He's the parent function, right? What's going on? I see a 3 on the inside. So horizontal, shrink. You got to flip it to 1/3, right?
So isn't it shrinks by 3 when you consider it and multiply
Shrinks
it by
by
1/3?
3. We'll say dilation by 1/3. That's a better way of saying it. So you say shrinks by 3 in the sense that it's cut into thirds. But I like thinking of it as like what to multiply by, so that's why I like to keep reminding 1/3. And then shift up 1. Did anybody get stuck on letter D, what they were asking? It was a little bit weird. It's kind of like parent function. How would you express it without the square root? And say, oh, hey, f of, put that little 3x inside. So you can show the 3 being multiplied on the inside and the 1 on the outside. You're just kind of showing it in a general form instead of the specific square root form, if that makes sense. I know it's a little weird. Do we have more evens? Oh yeah, it goes to 70 or something.
Wouldn't it be? Oh, never mind. You don't consider the square root right there?
This one, you're just trying to show it in function notation, so you're not actually putting the square root, you're putting the f of instead. It's kind of like a substitution. Number 58. This one, I don't know, I kind of like these ones because it's just you take the words and you figure out what it looks like in math. Instead of having to write the long, you have to write the short and be like, haha, math. Nice. But anyway, vertical stretch, there should be an 8 on the outside. Reflection in the x-axis, but think through what's that mean? Vertical flip, right? You're going about the x, so it should be a negative on the outside. And vertical shrink by a factor of 1/4. On 58, were you given the graph and you had to figure it out? Or were you given the words? Oh, you're given the graph. Those are kind of hard that side. Yeah, it's not easy. Alright, we're given the words.
Oh yeah, Missy. I wrote here. And how do you find the
Transformation from a graph.
yeah if it's a square root of graph?
Okay, we'll peek at it. Hold on. Let's look at number 7. Actually, number 70 is long. And he's like a beast word problem. Let's go look at Lucas. Lucas' last question real quick.
Oh.
Right in the bottom left corner. Right corner.
So Should I turn it to you?
There we go.
To project.
Which one says NG
Oh yeah, on the screen.
right there?
I forgot it. Or we can push it back.
No, that's not right. That's HTTP.
I hate when that happens to like my charger, my phone. I move it like a little bit, it stops charging. It's like zoom, zoom, zoom.
There it is. That's it. Here we go. That was like around number 58. You guys had some other ones, right?
It's like basic system.
Oh, come on.
That was good.
Lame.
At least you remember something.
Okay. Remember.
It was hard.
This one was hard. Remember. Think about the representative points. Okay? What do I mean by that? You have a point 416 and somehow it comes out of a square root function. The normal square root function. Now, could I plug in 4 and get 16? No. Right? That doesn't work. So what changed? What happened? Well, look at it. What do you see? Hold on. What's the parent function look like? The normal one. He's down here, right? But what points does he have? Plug in 0, get out 0. Plug in 1, get out 1, right? Plug in, what comes next?
2, 4.
No, square root of 2.
You get an irrational.
Plug in 4, you get 2. Does that make sense? Square root of 4 is 2. So what's happened to this guy? If he's, instead of at 1, 1, he's at 416. Where was 4 before? 2. How can I take what was and make what is? You could add 12, but what would happen to this guy? That's not right. He still does it. Or you could multiply by hence. Does that make sense? Because you could shift up 12 and you would get to this point, but it would be like a little up here. It's not the huge stretch. So I knew there has to be multiplication. It had to be multiplication. The other way of thinking about it is way too hard. There could have been a horizontal compression, but that's too hard. Vertical stretch is way easier.
Wait, why is it 8? Because it's
The old point was 4, 2. To stretch it, I have to multiply. So I say 2 times what is 16? You see it? So then I need 8 to be multiplied by the y value to get that point. So then what happened to this guy? 2 became -1/2. Well, how does that happen? Vertical flip. And 2 times, if you want to put a little like 2 times what is -1/2. You can solve for it, right? What times 2 would get that? Divide by 2. Same thing as multiply by 1/2. And you get a is equal to -1/4. That is my vertical stretch. Kind of makes sense?
Easier than what I thought.
But it's hard when you just look at a picture and say, I don't know, how did it become? But if I look at a few points and then look at what was and what is, maybe that helps. Make sense? A little better? Okay. Since we're here, do we want to look at anything else? Since I have the questions up? Just answers for 70 and we're done? We'll say yes. You guys are not participating anymore. Uh-oh. Okay, number 70. Yeah, 70 is a bit of a piece. Maybe a little bit more. Is that too much? Huh. Okay. 70A. They gave you the function, right? Okay. I see a shift up. I see a shift right. And I see a vertical flip along with a vertical, technically shrink, but we can say dilation by. What's my parent function?
X squared.
X squared. Are we getting parents function's okay, even though like the numbers are weird? So then if you did, and I think you guys were able to use your graphing calculator, right? Those numbers are awful. We see a downwards parabola. Hopefully that makes sense because we have a vertical flip. A downwards parabola. The vertex is over here somewhere because it's shifted right and shifted up. So it's shifted over and then up. Downwards parabola. Average rate. Hey, that's in section 1.45. How do we find average rate? y2 minus y1 over x2 minus x1 is just slope. But we don't have y's specifically. What do we have this time? N's. So we do n of whatever number they gave us, 3 minus n of, well, yeah, put 10 first, that'd be better. N of 10 minus n of 3 all over 10 minus 3. And that's plug in and chug in, which I know you guys can do. And if you guys look at your actual value, where's the word problem? It was measured in something. Was it measured in millions? I think it's measured in millions. So then you can go ahead and move it 1, 2, 3, and 4, 5, 6. So there was a little label tacked onto this to the point that 976 became 976,000. And letter C, based on the problem, it was just basically asking in 2018, which we plug in. Remember how many years after 2000? That weird. Don't plug in this big number. Plug in the 18 only. Plug in chunk. Measured in millions. They say, based on that 117.7 million, you could probably say no, but that was kind of like a judgment call, so that might be a little different based on you. All right, I knew this homework was going to take a while to go over at least the evens, and I knew the warm-up was going to take a while, but why did we still do it? It was tricky. Right? It was tricky. It's fast. We're not done. Come on. But I haven't put a due date. You guys know this on the board. Wait. You guys are just asking for a weekend, Sunday night, where you have to stay up all night. What are you thinking? Okay, anyway, come back. Oh, you do it Saturday? Let's see what section 1.8 is.
I get to study for that.
I have to go.
We're not done. We're starting. I just said there's no due date. And you all inferred something. Maybe I implied it. Here we go. Slightly. A little bit.
Oh, I'm loving this class.
Even after that warm-up today? Are you sure?
Miss D, no, because yesterday was so weird, like, okay, I'll have so much homework and I still have to study for a unit test for Gov that I need to
Oh, but
prepare
now
on.
today you're like, huh, I can do it.
So I was like, I'm gonna get homework done in lunch or I'm gonna get homework done like before practice.
Look at this guy.
Thank you.
You ever stay up late on Sundays because you leave homework till the end?
Nope.
No. I don't vibe with that. I don't vibe with that. Sundays are rest. Sundays sound.
It's okay, admit your weakness or else you'll never grow. Life lessons. Okay, come back.
Saturday I have an ACT, so Saturday I have an ACT, so Friday I'm not studying at all. Saving my brain.
It's like
My
my
Oh, Miss D, by the way, tomorrow?
You guys are writing, right? Not just randomly talking.
Yeah.
If we can write and talk, I don't mind. If we can't,
I have the ACT prep book.
Questions on math stuff?
Yeah, in math. Can I bring it to you tomorrow?
Or 7:30 or lunch.
Okay.
All those are good.
Yeah, but tomorrow's a walkthrough, so.
Not too bad. Arithmetic? What? What's going on? Section 1.8, combinations of functions. How do we combine stuff together? Well, we start with just the arithmetic operations, which you see below, which is plus and then minus and then times and then divide. What? Go team. Now what's missing? Putting one function inside of another. So that's coming. What else is missing? I don't know, square roots, sines and cosines, logarithms, exponentials. There are lots of things we can do, but we're starting off at the beginning. plus minus times divide. Why am I having you write this? You guys know how to add two things together, yeah? But do you know that this notation means the same thing? That's where it gets weird. The notation might be a little funny. Because this does not mean f plus g times x. This is function notation. So it's f plus g of x. This will be hard to do. This will be easy. But you have to know they're the same. Similar for all the rest. So you're not multiplying by x. It's still of x. It's function notation for finding the sum of 2, the subtraction of 2, the product of 2, the quotient of 2. Okay? And I bet most of you looking up here like, I can add two things together, subtract or multiply or divide. Cool. But when you get to homework, unless you remember the notation, you're going to get confused. So take a second. Write it down. As you're writing, just have one little question. Why does this one have a little thing tacked on at the end?
Because if it's 0, it doesn't.
Domain problem. Yeah, you can't divide by a 0, right? So if you divide two functions, you just introduced a domain problem. So it's going to work everywhere except for where that bottom is. Okay, this is all notation. Do we have it? Don't worry, we have time for examples. My daddy and Thomas are like, acting up now. Ready, set, and?
No.
Get it from a neighbor, go. So how hard is this? Hopefully not awful. But could this have posed some problems if we hadn't written the page before? Maybe. Notation is funny, but hold on. Nicole, stay with me. We got this. What do I do with F and G? I add them. Like that's it? That's it. Like I do 2x plus 1 plus x squared plus 2x plus 1? Oh, minus 1, sorry. That was the answer. Yeah.
You just plug in 3.
And then we plug in 3. But I wouldn't plug in 3 until you have it simplified, right?
Okay.
Let's make our lives better. Or the ones canceled. So then that's f plus g of x. So then if I want to evaluate, hold on, does the notation make sense? Am I multiplying by 3 or am I plugging in 3? Plugging in 3. 9 plus 12 is?
21.
Whew. It's okay, you were still right. Just kidding. Mental math is not meant to be everyone's strength. Does that make sense? The notation. So if you see two functions with some operation and then a parenthesis that does not mean times, what does it mean? What words do you put in there? Of. And think substitution and think plugging in. Does that make sense? Now, what was the title of the section? You guys should have it right there. This is one way of combining. Oh, okay. New notation, a little bit funny. Some of you might remember it from last year. So what have we not gotten into? Oh, hold on, that's just an example. Ooh, composition. But we'll get to that tomorrow. Okay? But hold on, wait. Quotient. Do we have time? Do we have a whole minute? Hold on, we'll wait 2 seconds and see. I never know. We have a whole minute. Ready? Using the exact same functions that we just had, which were f is 2x plus 1, and g is x squared plus 2x minus 1. I want you to find the domain of just as a quick little oh hey, if I make a fraction, I actually make a problem. if the denominator can be 0.
How would that be?
Who is he? Who's on top? Who's F?
There's an asymptote involved.
Who's G?
Is that the problem?
Oh, we're using this.
There's an asymptote.
Factor! Wait.
Back to that point. Factor in.
Whoa.
X cannot equal.
1.
Woo! Get out of here, buddy. Homework due on Monday. Spoiled rotten, but start tonight. Fine.
That's not that bad. I thought it was.
Yeah, but I can see it on my head to do Sunday.
Maybe do a little bit tonight.
Nah, we're not doing
Don't savor all your money.
Yes.
Savor a little.
No, but I have a unit.